All right, let's talk about Gary Payton. He was nicknamed the Glove. He was a great point guard. Mostly played for the Seattle Supersonics. In the mid 90s, he was paired up with Sean Kemp. And they had Detlef Schrempf on their team, I remember. Anyway, in the 90s, they were really good. They made it to the NBA Finals, but of course lost to the Chicago Bulls. I want to say that was 96 NBA Finals. Bulls beat them 4-2. Anyway, this guy was nicknamed the Glove because he was so good at defense, so he would get a lot of steals. Anyway, Gary Payton, he ended up playing on the Lakers in 2004. He was chasing a title with Shaq and Kobe. They made it to the finals again, but they lost in 04 to the Pistons. But anyway, this was like a important rookie card because Gary Payton, everybody knew he was going to be good, and he turned out to have a great career. All right, Gary Payton, the Glove. All right, lesson 13. Here we go. Here are 2 polygons, P and Q. Select all sequences of translations, rotations, and reflections that would take polygon P to polygon Q. So what you want to do on this is you want to trace P with patty paper. So there's P. Get all the points. A, B, C, D, and E. I just like to trace even the point, even the letters specifically. And then I connect the dots like so. I don't try to hand draw the line segments. I do use a straight edge. There's line segment BC, line segment CD, line segment DE or ED, and line segment AE. Okay. So you got P traced on tracing paper. All right. Now, rotate 180 degrees around point A. So I know B is going to end up over here. Let's see if this works. Will it take polygon P to polygon Q? There's a 180 rotation, point A. Rotate 60 degrees counterclockwise around point A, then reflect over FA, okay? 60 counterclockwise, center point A will go there. How do I know that? Because each of the angles of the equilateral triangles are 60. And then they want me to reflect over FA. Okay, so A prime, B prime are going to stay put, basically. So here we go. A prime, B prime are going to be on FA. Does that take P to Q? You tell me. All right, that was the second one. Here's the third one. Translate so that A is taken to J, okay? A to J. Then reflect over line BA, okay? Reflect over line BA. Does that take P to Q? Okay. Fourth one. Reflect over line BA and then translate by directed line segment BA, okay? So there's a reflection over BA. And then if we're translating by directed line segment BA, then that'll go there. Does that take P to Q? E, reflect over BA, then rotate 60 counterclockwise around point A. Okay, if we reflect over BA, we'll be here. Then we got to go 60 counterclockwise. So see that B right there? That's going to end up right here. How do I know that? Because this angle is 60 right here. Anyway, that's your final position. Does that work? So, lesson learned on that problem. Trace P, follow the moves, and see if P goes to Q. All right. Number 2, the semaphore alphabet. You may never see that ever again. We'll see. Is a way to use flags to signal messages. Cool. Semaphore alphabet. Here's how to signal the letter Q. Here. Describe a transformation. So that's your action. Describe a transformation that would take the left-hand flag to the right-hand flag. So you want to restate it. So a transformation that would take, don't get creative, just copy, the left hand flag, this one, to the right hand flag would be ... Create a sentence frame. A transformation that would take the left-hand flag to the right-hand flag would be... Now, what do you do on that to figure that out? Well, watch this. Here's your intersection point of the flags. Do as I say, not as I do. Using freehand in the interest of time. So what if we rotated counterclockwise? Center is the intersection of the two flags. So we rotated counterclockwise. But you need this angle right here. So put the center on the center, line on the line. The center on the center, line on the line. That goes here, which is 135. 135, right? Boom, right there. So, we're going rotation. Center is the intersection of the two flags. 135 degrees. And then I think I'm going to reflect over the right arm. So write those 2 steps down. Rotate, reflect. You need to nail 1, 2, 3, center, direction, degrees. And for a reflection, you just have to note the line of reflection. That one I'm going to give to you. That was the right arm. So if you can get the rotation, the center direction, degrees, reflect over the right arm, then you're done. All right, next one. Number 3, match the directed line segment. Zoom out a little bit. So match the directed line segment with the image of polygon P being transformed to polygon Q by translation by that directed line segment. All right. I will do one of these. So we're going from P to Q. You got to find the directed line segment. Yeah, do as I say, not as I do. Should use a straight edge for these. But in the interest of time, I'm going to hand trace. Okay, so we got to go from P to Q. So what was that move? Well, this point went to this point. So the translation is by this directed line segment right here, which is that one. So this one is C. Or if you want to go like this, translation 4 is C. So get the other 3 and you're done. Okay, number 4. Draw. Zoom in a little bit. Draw the image of quadrilateral ABCD when translated by the directed line segment V. Label the image of A as A prime, the image of B as B prime, image of C as C prime, image of D as D prime. That's so easy. Every single point's going to move 3 units that direction. So A prime will be 1, 2, 3, right there. You do the rest. You're going to get 3 more points. And then you're going to connect the dots and shade it in. Okay, number 5. Here we go. Here is a line L. Plot 2 points A and B, which stay in the same place when they are reflected over L. That is so easy. If you reflect over L and you need the points to stay put, they just have to be on that line. Plot 2 other points, C and D, which move when they are reflected over L. All you need to know is that as long as C and D are not on line L, they will move when reflected over L. So just put C anywhere not on the line, put D anywhere not on the line. I gave you that one because that was a lesson we didn't cover. All right, 6. Here are 3 points in the plane, A, B, and C. Select all the straight edge and compass constructions needed to locate the point that is the same distance from all 3 points. Okay. All right, I'm going to do it for you. Here's how you could do it. Try to watch what I'm doing here. What was that move called? was that move called? All right. This point, we'll call it D, right here, is equal distance from A, B, and C at the same time. There you go. What were the three things I did right there? You might have to go back and rewind the tape, but there are three moves I did to find that point. You gotta find them. A, B, C, D, and E, F. 3 out of the 6. So circle 3 out of 6, A through F. To get this one right, you gotta circle 3 out of the 6, A through F. Alright. 7. This straight edge and compass construction shows quadrilateral ABCD. Is ABCD a rhombus? Explain how you know. So, rhombus. 4 sides, same length, opposite sides parallel. Okay. So I automatically know that AB has the same length as BC because they are both a radius of circle with center B. So I know that. I also know AB is the same as AD because these are both a radius of the circle with center A, this one. And lastly, I know that CB is the same as CD because they're both a radius of the circle with center C. So we proved that. Now, can you prove that the opposite sides are parallel? Well, let's see. You can say that AB is translated by directed line segment BC. Therefore, this line is parallel to this. Because if we translate a line or line segment, it is translated to a parallel line. All right, let's look at BC. We can say that BC was translated by directed line segment BA or CD. And because BC was translated by directed line segment BA, that means that BC is parallel to AD. Because if you translate a line segment by a directed line segment, it'll be taken to a parallel line. Woo! Tough one. 21 minutes, no big deal.